Okay, hello everyone. Hope you have scanned the QR code. Uh, Today, actually, we will go discuss another section. So uh, I will end the section about the curve sketching. So we'll move to the next section. It's actually the 4.4. The curve sketching is 4.5. So we move backwards 4.4 because I haven't uh, give you any details of the section 4.4. Okay, let's start. Okay. Let's start with the feedback first. Okay, from the last Friday. Uh, F has an absolute minimum value at C, then F prime C is 0. Okay, it's surprising that most of you uh, choose the answer true. Remember, okay, if you have the functions, okay, let me draw functions. Okay, and it's going there. Oh, maybe yeah, it's going there. Okay, here, okay, in this point here, this is absolute minimum, right? But f prime c is not 0. Okay, okay. So it's not necessarily true that if you have an absolute minimum, it should be f prime c is equal to 0. Not always. Or okay, or maybe your point is maybe at the end point like this. And we are not sure this is f prime c is 0 or not, right? So this will be also absolute minimum if we have a domain or interval. Okay, so the answer will be false. Okay. Okay, that's the first question from last Friday. Okay, and the second question, this is asking when the f is increasing. Okay, so f increasing should be slope is positive. Right? So if we need to find this is this is f prime, so we need to find the f prime that is a positive. Okay, so we will find at this is if this is 1, 2, 3, 4, 5, 6, 7. So the one that positive is this one and this one, right? So 1, 4, and 4. Okay, that is the answer. Okay. The other one here is negative. This is also negative. Okay. Okay, I think you did good job here. Okay. 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 The next question. This is about the. It's actually we need to find the max value, right? And we need to find A and B so that the max value is equal 1. So this 2 here is 2 is critical point, right? Okay, based on the information here. So 2 is a critical point. So we can find first, we can put in the x equal 2 into the equation first, if you want. This is 4b, or this is 1. So this is half. Okay. And then you can also check the when the f prime is equal 0. So we can find the f prime. So we can check with a product rule. So if you have, this is f, this is g. Okay. So we can find the f prime. So a e bx squared plus ax, and then 2bx e bx squared. And when the x equal to, this f prime will be 0. So let me write here, this is f prime x. And then let me put f prime 2. This will be a e for b plus, let me calculate this, 2 abx squared. And then this will be e bx squared. Okay. 2ab, 2, 2, 4, 8ab, e to 4b. This should be equal 0. Now look at this. We have a e with power 4b, and this also same. So I can substitute. Okay. So I can substitute. This is half. Okay. Plus 8 a b e 4b. And lastly, I can write maybe here 8 a b e 4b is negative half. So a b e 4b is negative 1 over 16. Oh, wait. Okay, hold on a minute. Okay. Okay. So who just coming? Please scan the QR code. Okay, let me go back to here. Wait for a moment. Let me check first if there's a mistake here. A e b x squared ax e b x squared 2bx. Then a mistake I make. Oh, maybe let me simplify this first. Okay, so I think this should be right as. Well, let me erase first. Okay, so make it more simple. I think this will be looking better. Okay. Before we start to substitute the number, I think we can look at this first. Remember that we have, if we have 2 inside, then it will be 0. And if we have 2, it will be 1. So we can look at this. And if we look at this one, so we know that, we know that this 2bx squared plus 1 is equal 0. So let's put into, this will be 8b plus 1 equals 0. So b will be negative 1 over 8. Yeah, if we done this, then we know that the factor 2bx squared plus 1 is making the equation 0, right? Okay. So we got the b equal negative 1 over 8. Then we can substitute to a, e of, this will be negative half like that. So we will have a is, now this, you need to be careful, okay? This is having a negative. So this is actually a over square root of e. So it's actually a will be square root of e divided by 2. Okay. Okay, so you need to be careful on the first derivative here and this e with the negative power here. Okay. But actually, if you have the time, because you have given these 4 options, you can check one by one. You can check one by one. B, A with x is 2, and then the f of x should be 1, right? You can check A and B for all these options if you don't really have any clue left on how to solve this. Okay. Okay, so this is A. Okay, any questions? Okay, if there's no questions. Okay, before we move on, I want to know which one is Shami. Can you give me your student ID? Okay, anyone? Is the student here? Okay. Everyone. Okay. Okay, thank you. Okay, let's go to the next slide. Okay, we are going to, let me give you first, before we move on, let me give you two functions, okay? Two functions. That is, simple functions that you might graph these functions as well easily, right? And the second one is just ln x, okay? And then imagine if we have a limit, we want to evaluate the limit as x is going to approach 1 of this f of x divided by G. Of course, some of you already familiar with the L'Hopital rule, right? But what is actually L'Hopital rule? Okay, and how we can approach the L'Hopital rule? Okay, so first, let's try to draw. Okay, let's try to draw the graph and see at this x near 1, what is happening to the graph. Okay, so we can check with the graph. Okay, we can check with the graph. Okay, this quadratic we can easily factor x plus 4 and x minus 1, right? So we will have a minus 4. I think I can move this to a little bit there. And taking this is 1, 2, 3, 4. This is 1, 1. Okay. And the maximum value will be at negative 3 over 2, right? This is the middle of the 1 to 4. So it will be around maybe here. Okay. And if you have this 9 over 4 plus minus 9 over 2 minus 8 over 2. Maybe 17 over 2 is negative 34 over 4. So negative 34. Negative 25 over 4. That will be around 5 something. 5 something. 5.1, that will be really down here. Okay, let's say at this point here. And let's try to draw first. Okay, more or less that or let me just draw with this. Okay. Okay. Now the G is just ln x. Okay. ln x will be having at least you will have maybe from here. Wait. From here and then crossing this x equal 1, and then it's going to have it's not really smooth, sorry, maybe like that, maybe not too smooth, maybe here. Okay, I think that's okay. Okay, so the blue is the F and the green one is the G, and this is precisely the x equal 1. Okay, now to imagine what is happening on this x equal 1. Now let's look at closely. Okay. Imagine maybe we look from the right side. We look from the right side. So we are approaching from the right. Okay. Let me start from the right. So you're moving from here and then approaching 1. Okay. So we are approaching 1. Okay, let's see G approaching 1. Okay, the G eventually meets the f of x of 0 at x equal 1, right? And f also similar. But what I want you to observe is when they both come, they both approaching a short distance. Okay, they both approaching a short distance. Okay, when we looked at this, maybe let me mark this in. So observe this. Okay, imagine you are zooming in, zooming in, zooming in into this circle, the red circle. Okay, if you see the line, okay, you see the line, and you imagine the slope. Okay, the slope. Okay, so if I imagine the slope from the G, for example, from here, the slope is eventually when the slope is near 1, the slope is something linear here, right? It seems in our eyes, okay? Because we have limitation on the pixels, right? Okay. But eventually in nearby the x equal 1, the slope seems it's just a same slope, right? And you look at this also, and eventually at this point here, okay, this point here, if we use our ratio, if you use our ratio f over g, that is our questions, right? Limit x approach 1 of f of x divided by g of x. Okay. If we look at this ratio, if we look at this, let me change color. This is we have imagine this is really small dg, okay, and this is also dx, and we have a small small here df, and this will be dx. Okay, so the slope for the f is this df over dx, the gradient, right? The slope. The slope for g is dg over dx. And if you look at the slope here, we can see that at the very, very near x equal 1, we can say that our f over g is the same ratio with the df over dx divided by dg over dx. Okay, so from visuals, from just only the graph here. We are not going to dive into the formula yet, okay, but I will later. So from here, we can actually say that maybe let me write at x nearby 1, okay, f of x over g of x is, it looks like, okay, if you look at the graph, it will be the slope of f and the slope of g. Okay. Okay. So if you look here, what I mean by that is it's looking like the line is, or the curve is, it as a visual, it's similar to the slope, right? It's linear. If you look at this really close to this x equal 1. So what we can do here is maybe at our conclusions that if we have this as x approaching the something here that is approaching the same point here, that is making f of x is equal 0, then we can make some approach that this is actually the same ratio of the slope itself. Okay, okay, that is actually L'Hopital rule. That is actually L'Hopital rule. It came from that phenomenon. It came from that phenomenon. So we can say that, okay, from the graph, we can say that, okay, it's same this as the slope, okay, the ratio of the slope. So this is slope of f. This is slope of g. Okay, now let's start to look at the formula on the L'Hopital rule. And actually, the one who are inventing the L'Hopital rule is not L'Hopital. It's funny actually. So you know the Bernoulli, right? In physics, you know the Bernoulli. He's the one who invented L'Hopital. Actually, he is the one who invented it. But the, but during that time, he needs money. He needs money, so he sold his patent to L'Hopital, and L'Hopital buy, and okay, it's become L'Hopital rule. So the one who are actually inventing is the physics Bernoulli. So the L'Hopital is uh, he has the money and he buy the formula from L'Hopital, from the Bernoulli. Okay, okay, that's just for your information. Okay. Okay, now the L'Hopital rule itself. Okay, Uh, let me write in my notes in a simple words. Okay, but later we can see on how the words, the official L'Hopital rule in your textbook. But let me write L'Hopital rule. So L'Hopital first. Uh, let f and or f of x. Okay, so f of x and g of x. This is both differentiable, okay, and continuous. Okay, so we need to have uh, this two property. Okay. And let's say if we plug in some a, this will be equaling 0. And the third requirement, uh, the first derivative of g a of g prime a is should not be equal to 0. Okay, in terms of how we are using, let me write the practical use first, and then let's see the how we find the L'Hopital. Okay, so limit as x approaching a of f of x divide g of x by L'Hopital. You can say that the first you need to make sure. Okay, if you plug in a into f, and if you plug in a into g, this should be 0 and this should be 0. Okay, 0 over 0 here. And then by doing this L'Hopital, we are actually doing the one that we are observed before. Okay, so we made to find the first derivative or the slope of f and slope of g. Okay, and we are going to do that and write this as you still need to write the limit, and this will be f prime x, and this will be g prime x. Okay, this is how you are doing it. But how we find this derivative? Okay, let me write in a simple words, so that you may actually maybe easily to remember if you want to you want to understand more. So limit okay first because fa and ga is 0, then I can make this happen. I will minus this with f of a, or I will minus this with 0. I will minus this with 0. I can do that, right? Because it's just 0. And then 0, we can also conclude that fa and ga is 0. Then we can also change this into this. Okay, and then we can multiply with this. Okay, now remember, this is the definitions of derivative, right? If we have limit, so we can say limit x approaching a of f of x minus f of a divided by x minus a is equal with the derivative, the first derivative of f, right? This is the first derivative of g. So f prime and g prime. So we can say that this is actually f prime a divided by g prime a. This is not really full proof of the L'Hopital rule, but I think it's still useful if you want to uh, imagine the L'Hopital rule. Okay. Okay, the next one we will do some elaboration, okay? Because this is we say that this is the we say 0/0 problem. Okay, so when you try to put a into the function, it will have 0/0 situations, and that's why you can do the L'Hopital rule. If you plug in and it shows that 0 over maybe number, then it's just 0 limit. Okay, so you can do L'Hopital rule when you have 0/0, and also some other forms. We call these forms indeterminate forms. Indeterminate forms. Okay. Also, it's also uh, applied for this infinite over infinite, or it is have the plus minus plus minus. Okay. Okay. So if we have 0/0 or infinity over infinity, we can use the L'Hopital rule. Why this is? We can say this is uh, similar case because infinite and 0, it has some similar property. When you have 1 over infinite, it will be 0, right? So it's actually applicable to the with L'Hopital rule also. Okay. 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 Let me give you some few example. Not really that complicated. Okay. For example, limit as x approaching 1. I think this is easy. This is if you check. So first, always check the limit. Check the x. So this will be 0/0 situations, right? That's why we can directly say we can do some L'Hopital. Usually you write these words L, H to make notes that, okay, we are doing L'Hopital process here. So L, H, this means we are doing the L'Hopital rule here. Okay. So we can have, this is, wait, sorry. It's 1 over x. This is 1. So this is 1. And similarly, if you have limit as x approaching infinity of e with power of x divided by x squared. Okay. Now we check the infinite. Both equations gave us infinite over infinite. So we may continue the L'Hopital process. So derivative of e to the x is just e to the x. And this will be 2x. Still infinite over infinite. Do the L'Hopital. So you can do L'Hopital as many as you can. As long as it is appearing 0 over 0 or infinite over infinite, you still can do L'Hopital rule. Okay. Okay. Now, at this point here, we arrive at infinity over 2. So we can just conclude that this will be going to have an infinite result. Okay, now another example, limit x going to infinity and x divided by say square root of x. If you see the functions here, ln infinite, and then you have square root of infinite, it gave us the infinite over infinite situations. So this is also infinite over infinite situations. We can use the L'Hopital process. So this will be 1 over x, and this will be 1 over 2 square root of x. We can, if you look here, okay, it's tempting for you to check that this will be 0 and this will be 0, right? 0 over 0. You may L'Hopital process, but actually, what you need to do first is probably you can simplify because you have x, you have square root of x. You can cancel that out, right? So we can simplify this and become this. And this is actually 2 divided by square root of x. So 2 divided by infinity will be a 0. So this will be resulting 0. Okay. So whenever you find this reciprocal 1 over 1 over, try to simplify first and evaluate. Another example. Okay, now we can see that from here it's actually approaching 0/0 situation. So we can do, if you want to do the L'Hopital rule here. So tangent becomes secant the tangent becomes secant squared x minus 1, and this will be 3x squared. We check the formula. And still, it gives us still 0/0, right? Still 0/0. You may do L'Hopital as many as you want, because it's still, we still have 0/0. So this will be 2 secant x, and then secant x is secant tangent, so this will be secant squared x tangent x. This is 6x. Okay, now you can see that we can see this 1/3 limit x0 of the secant squared x, and then multiply with limit x approaching 0 of the tangent x over x. And we know that this is basically equal 1, right? Okay, this one is equal 1, if you remember. So we will have 1/3. This is equal 1 also, right? If we plug in 0. If you maybe confused on tangent x over x, this is actually similar with the sine x over x. The same situation here. Because tangent is sine over cos, right? So you can write this answer will be 1/3. Or from this secant here, let me write another section here. We can simplify the form first. Okay. we can go for this form. So we can write this +1 minus 1 is 0, like that. And this will be 3x squared. And you can solve this by the trigonometric definitions in limit. We know that this is equal 1. Or we can write this. We can separate, and this will be 1 over 3. This will be equal 1, equal 1. So it's 1 over 3. So either you can L'Hopital several times, or you can also rewrite the form, simplified, use some identity for trigonometry, and you will get the same result. The same result. Okay. Okay. I hope you get some idea from this example here. Okay. Any questions? Any questions? Maybe from the online students? Okay. Let's continue. So this is the general interdeterminate forms, 0 over 0 and infinite over infinite. Okay. So it's all the example for 0 over 0 or infinite over infinite. Okay. The next one will be called the indeterminate products. This is type 0 multiply with infinity. Okay. If we have, for example, if f or if limit, okay, let's say the limit x approaching a of f of x is 0, and limit x approaching a of gx is infinite or maybe negative infinite, then this will be confusing if we are going to evaluate f of x multiplied with g of x. Okay, now if we take some example, for instance, uh, let's say we have x squared and then 1 over x. Let's say we have a limit as x approaching 0 from right of x squared, this will be 0, right? If we have limit as x approaching same number for 1 over x, this will be infinite. If we have this, we know that we can simplify the form first. We can cancel this x, and we know that this will be resulting 0. So actually the problem for this kind of limit, the limit of f is 0, limit of g is infinite or negative infinite, which means if you want to multiply this f and g, and you have the limit, the same limit, it's not 0, sorry, a. So you will think uh, maybe if f win, then it will be resulting in 0. If g wins, it will be resulting in infinite. But we are not sure yet. Okay. So for example, in this case here, this x squared is getting 0. 1 over x is getting infinity. If we multiply both of them, which one is getting first to 0 or to infinite? If we simplify the form, okay, we can still having the answer that it will be getting 0 first, right? Okay, let's try another one. Let's see and how we can solve this. If this is happened, it's 0. Another one here. Say we have the 1 over x like that. This is actually infinite, but when we have multiplication here, we know that this will be resulting 1. So there is some compromise if this happens, but for other functions that is still in the relation with this limit, if limit x approaching a of f is 0, limit x approaching a of g is infinite or negative infinite, what can we do to solve this? We can write f multiplied by g as, we can write f and divide by 1 over g. We can write like this, or we can also write as this. So again, the solutions is we are going back to the 0 over 0 or infinite over infinite, and then we can do L'Hopital rule, okay, by doing that. Okay, the example, let's say the example is just a simple one, an x. We can make this into this. Because when we are going to have this 0 approaching, x approaching 0, so ln 0 is infinite, 1 over 0 is also infinite. So this will be infinite over infinite. Then by doing so, we can take this to L'Hopital process. This will be 1 over x. This will be 1 over a negative 1 over x squared. And this will resulting, or we can simply say that will be 0. So from here, from x, ln x approaching 0, so it will getting 0 first rather than going to infinite. Okay. Actually, you can also try if you want to check this. But if you go from this one here, you will getting more complicated results. Okay, so I believe this will be much more simple process rather than going to this. This is also can you can do some. If you check 0 to x 0, this is infinite, 1 over infinite 0, so 0 over 0. You can do L'Hopital, but I think it will be more complicated process if you check the result. Okay, so that will be the indeterminate products, 0 multiplied with infinity forms. Okay. Okay, another section. Okay, so indeterminate difference means this is infinite, negative, infinite. Okay. Okay, before we are going to look at what the example are, the indeterminate difference is when you have an infinity expressions minus another infinity. Okay. The first thing, do not take this infinite as a number. Okay. So this is actually, you cannot really count how many infinite is. So if you see this expression, do not make the final result as 0. Okay. So that's a wrong approach for the infinity. So if you have this at your limit, do not make this. Okay. So this is wrong. Okay. Because sometimes happen. Okay, so if the limit and another limit and okay, so it's called, this is called the indeterminate form type infinite, negative, infinite. Okay, so the answer, if you imagine any big number, we can take this. Okay, if this is infinite, infinite, will be there a positive infinity, negative infinity, or a finite number. Right? This is the possibility that it may have from this limit expression. Okay. Okay. To solve this, Let me just give you the example. Okay. Okay, we start from 1. Okay, so 1 going to be ln1 here, and 1 minus 1, 0. So this will be resulting infinite minus infinite, right? Okay. Now to solve this, we may rewrite the form. Okay. Okay. Now, if we check, we have a 0 over 0 situations. Okay. So if you have the infinite minus infinite situations, one way to solve is to rewrite the form. Okay, rewrite the form. In this case, we are just going to have the common denominator and then rewrite that form and see if the form has something like, for example, this is becoming 0 over 0, then we can use L'Hopital rule. Okay. So the key of L'Hopital rule is actually you need to think always 0 over 0 or infinite over infinite. Any types forms that you think, oh, it is just indeterminate forms, you need to change that forms into 0 over 0 or infinite over infinite. Okay, as a conclusion, as a short conclusion. Okay, I will let you see the examples more. Okay. Okay, so we can write this with the L'Hopital process. This will be, let me write the x1. So this will be 1 minus 1 over x. And this will be a product rule. And we can simplify one more time. This will be x minus 1. And this will be x minus 1 plus x ln x. And I think we still have 0 over 0 here. So again, we can do some L'Hopital rule. Okay, I think we can get the results here. This is 1, so it will be equal to 1 over 2. Okay, another example. Now, how to solve this? We can solve this first by graph. By graph. Okay. Uh, you can make some argument that e to the x is actually increase really fast, right? Increase uh, significantly. Significant compare with x. So it will go to the infinite. So e to the x minus x is going to have infinity. If you write this in an essay argument like this, I can accept it because it's correct. Okay. If you want to make uh, more more proof, we can look at this limit and factoring x outside. We can look this e to the x over x. Okay. So we can verify our conclusion here with this when we factor out this x. Okay. So we can see that the term uh, e to the x over x is approaching infinity as x approaching infinity. Because from here, you see that this is actually growing faster rather than this. And you need to multiply again with the x outside here. So of course, it will be going to have infinite. Okay. So if you just look at these expressions, the e to the x minus x, maybe we still have some doubt. Okay, we are still not sure of whether it's correct or no. You can either check with the graph of e to the x and compare with this equal the line equation of y equal x, and look at how fast the e to the x compare with x. Okay, or you can check the when you factor out the x, you will see that this is growing faster, okay, and going to infinity, and you have x approaching infinity. Of course, this will resulting with the infinity. Okay. Okay. Another section, another form. So this is the difference, infinite minus infinite. I think this will be the last form for the L'Hopital rule. Okay. So this is the indeterminate difference. Okay, the third one is called the indeterminate power. So we will have a limit, and we will have power functions. Okay? So we may check the limit if we have f. If this is 0, and then we have a limit of jx is 0, we have the now it's 0 with power of 0. Okay, let me write all three conditions. Okay, how to solve this? Okay, first let's see the conditions first. Okay, so we have 0 and 0, so we will have 0 with power of 0. Okay. The second one, we have infinity, 0, and we have infinite with power of 0. Okay. The third one, we have 1. We have 1 here. 1, and then with power of infinity. This is we call the indeterminate powers. Okay. If this happens, do not attempt to answer this equal to 1. Okay. It's different. I think maybe I can show you later on how we can, why this is uh, we call indeterminate powers. Okay. But you notice that there is no mentioning about this 0 with infinite, right? So this is later I will explain. But let me explain on how to solve first, okay, and then later I will give you the additional parts on some proof. Okay. So first thing is we can write the form of, so we have this f of x, g of x. So let's write in terms of y. And then, because we have a power here, like when you remember the implicit and the natural logarithm, we may have an ln here, and we can take this down. So it will be easy to observe or to evaluate. Okay? So let's take the ln. Okay. So take the ln. So we will have ln y is g of x and an ln f of x. Okay. And then we can put in the limit. We can put in the limit. Okay. So when you calculate this g ln f of x, the right part here, when you have the result, remember that the result is in the form of ln. And then you need to rewrite in form of y. That is the f of x with the power of g of x is basically e with the power of g of x ln f of x. Okay. This is y. So at the end of the results here, when you evaluate, you need to write into terms of e with power of this. Or if you want to write in one form, okay, without this assumptions, we can go here. We can directly write, for example, if this is already have a limit, we can write this in form of e and then directly limit directly uh, g and ln. Okay, let me give you example. This is 0 with power of 0. So we can take this, okay, we can take this and make it into the we can take this and x with power, or we can directly write the ln. And we know that from the limit, we can write this and only evaluate the power. X ln x, we can evaluate this. And we know from the L'Hopital rule, this will be negative, infinite, infinite. Okay, so we can do some L'Hopital rule. And this will be resulting with x, right? So this will be resulting with e with power of 0. So this will be 1. Okay. Or if you want to be more careful, what I can suggest to you is you can write the y is equal x with power of x. We can write this one by one. Okay. And then we can find the limit. And we got directly this is equal with, so after some L'Hopital, okay, We can write this. This is 1. Okay. So because this is 1, we know that limit of x 0 of ln y is 1. So limit x of y is e, sorry, not 1, 0. Okay. So either way, it's similar results. Okay. You can do this using assumptions of y equals functions, and then you can do some multiplication with the ln first and evaluate the limit and take the limit and making into the 0 over 0 or infinite over infinite. Okay. And then you get something there and put this result into E to evaluate the functions. Okay. Or you can directly write this x with power of x. You can change directly to E with power of ln x, and then you can simplify. And then remember, when you have E with power of a function and it's a limit, you can just imagine that the limit is actually just evaluating this. Okay, so E with power of limit, and then we can check this result, and we got that this result is actually just negative x, and that will be a 0. So the final result will be E with power of 0. It's 1. Okay. So let me give you the other example. Okay. I think I can show you a little bit. Okay, maybe a quick example. Some proof for this power, I will let you know later on Friday. I think we can move to some example first. Okay. Okay, and any questions, maybe? Any questions? Okay. Let me give you two questions. First is, let me, Yeah, for the first question, I think you need several times L'Hopital, I think. Anyone got the results from these two questions? Maybe online students, did you get the result? Okay, for today's class, am I too fast explaining? Too fast or no? Am I explaining too fast? Oh, it's all right. Okay. How about you? It's okay. Do you think fast? Okay. Okay. Right. Yeah, a little bit long. Yeah. Okay, for online students, have you checked the answer? Okay. I think I can show you a little bit on how we can solve the first one. If you look here, this will be infinite minus infinite situations. So we can maybe try to rewrite the form. And then by doing this, we know that this will be 0 over 0. So we can do some L'Hopital rule. So L'Hopital rule, this will be 1 over 1 plus x squared minus 1. And the bottom one will be tangent inverse x plus x Okay, now we still have something to do here. Multiply with 1 plus x squared, 1 plus x squared. And then this will be 1 minus 1 plus x squared. Tangent inverse x, 1 plus x squared plus x. And this is, I think, we can write directly minus x squared. Okay. Yeah, it's long. Okay, we can do this is 0 over 0 again. So L'Hopital, one more. Oh, let me write maybe down outside here. Let me go through here. Take the L'Hopital. Okay. Okay. I think this will be cancelled nicely. So we will have negative 2x divided by 2 plus tangent inverse x 2x. And we know that this 0, this 2, so this will be 0, right? Okay. Okay, the second one here, I think it's much more not that long. Okay, I think we can start with the y, making y, and take this ln. Okay, so we can compute this limit first. And we know that this is the 0 over 0. We can take the L'Hopital rule. This will be a limit. This will be 1 over 1 minus 2x and divide and multiply with negative 2. So this will be a negative 2. Sometimes, okay, sometimes you make a mistake that you just end the result here. So you answer negative 2. So remember, this is the ln. Okay, so we need to make the solutions for the y. So write this. This is actually e with ln y or e minus 2. Okay, any questions? I'll have a few more examples later on Friday class, and then also we can move to another section. I have your results already for the quiz. I will deliver later, maybe tonight. And I will also give you each uh, each report, so you will know which questions you get wrong. But I think there is one question that I set the answers. There is some mistake in this the answer. So your final result will be most of you will be getting at least higher. So for example, if the report says that you get 70% accuracy, maybe you will get 74 or 74 or 70 or maybe 80. I think only one question that is I take the answers incorrectly. Okay, if there is no questions, I think we can take the feedback time for today. Okay. Or do you have any questions, discussions? Yeah. Yeah, maybe next Friday. Okay. Because it's only a few minutes left. Okay. So Friday we will have some, I think, a few example and then some additional explanation about, I think, the indeterminate powers. Okay. Okay. Let me stop the presentations for a while. Okay. So yeah, please scan the QR code. And uh, because the midterm, I think we will have the midterm on 29, okay, maybe 29 for this class. Okay, so 2 weeks from now. So it will be covering all the chapters 1, 2, 3, 4. So from the functions, the limit, the derivative, and also the applications of derivative, the chapter 4. So chapter 4, like as the curve, uh, the L'Hopital, and also there will be other parts like optimizations in chapter 4. I think I will go to this optimization hopefully this Friday. Okay. And I think I can also add more additional videos for you to check, and I give you the practice, and you can check the practice and check my video also. Okay. Okay. Let's start. Let's start. Okay. 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 Are you ready? Okay. 3, 2, 1. Let's start. Yeah, of course. Blessing. We just doing that in our lecture today. Okay, the answer is 2. Yeah, you need to answer through this, kind of not to answer in the chat box. Blessing. Okay. Okay. Can see later. Okay. Later this, I will show you later. Okay. The next question. Okay. Okay. Bingo. Okay. Okay. Really fast. Okay. Okay. Just 2 questions. I think that's okay. I think time is enough. Okay, 20 seconds. Okay, I think. Okay. Okay. Okay, good. Yeah, that's okay. Blessings. Okay. Oh, okay. Okay, congratulations. Is the student here? Oh, okay. Oh, yeah, yeah, yeah. Eric, right? Yeah, okay. Okay, congratulations. So that will be the end of our course. If you need the QR code, wait for a moment. Let me give you. Okay, this will be the QR code if you need one. Okay, so if you come to the class in the middle of the class, then you can scan the QR code. And for the rest of the students, we finished it. So let's meet again next Friday. Okay. I think for the quiz, most of you did good job. I think the average around 70, so I think that's okay. Okay, if you. Okay. Oh yeah, blessing. Yeah, sorry for the quiz. Okay. Okay. See you. See you. Yes. Mhm. Oh, okay. Okay. I will check. I will check. Okay. Okay. See you, everyone.